Hello and welcome back to Let's Learn C. This is a program for beginners, and today we're going to be talking about typecasting in C. Typecasting pretty much means trying to convert a value from one type to another. And it really does come in handy. Sometimes you want to convert strings into integers. Sometimes you want to convert integers into float, or even float back into integer. It really is up to you, and it comes in very handy when you're doing arithmetic. So we're going to talk about some examples here, and hopefully it'll become clear once I show you. Let's get started. So here's an example of converting a string to an integer. So let's pretend that we got a string of numbers somehow, and in this case here, I've declared it in my code. So I've declared a character array called ID num, and inside of ID num, I have a string. Notice it has quotes around it. So I have a string called 435345. Now, since it comes in as a string, I can't really add to it, I can't subtract to it. It's string, it's just pretty to display. So if I want to do some arithmetic with that number, I have to take it out of the string format and put it in a numerical format. So the way to do that in C is to use a function called a to I. So I put the word a to I, and after a to I put parentheses, and inside the parentheses I put where is the string value currently being stored. So right above here I can see that I invented a character array called ID num. That's the name of my variable that I invented as a programmer, and ID num is a variable, and inside of it it has a string 435545. So when I call a to I put parentheses, and I say, what's the name of the variable that I invented? What was the name that I invented for this variable? So the name of the variable that I invented was ID num, and it matches that variable up there. So ID num is the variable that has the numerical string inside of it. As soon as I say a to I ID num, don't forget those parentheses, then it's going to convert this and then put it into whatever value is on the right-hand side, I guess it would be the left-hand side in your case, of the actual expression. So I have an integer called num. I'm inventing this brand new variable called num. It starts off empty, and at the time that I'm declaring it, I say go get this new variable called num and put in there what comes out of a to I ID num. So a to I ID num works first. It does its conversion, takes stuff out of string, puts it to number, and then gives it to num. And num now has that new value, the numerical value. So here it's still a string. We put that string into a to I, and it churns it. It does its thing to make it from a string over to a number. And as soon as it's done, it pops it to the other side of the equal sign and goes inside of num. Now my num has a numerical value. Num is an integer after all. So that's the numerical value, the numerical representation of that number. And so I get a number that looks exactly the same, 435345, but this time there are no quotes. It's no longer a string, it's now a number. So when you're converting from a numerical string to a number, all you gotta do is use a to I. I'm going to show you some more examples of converting, and these are broken down to two types of numerical conversions. So we have what was called implicit and explicit. Implicit means that it's implied. The compiler will know based on what the values are that you must have meant to convert, and it will do it for you. It's almost something that you don't even have to think about. The implicit means it's implied that these will convert because of the way that the statement is written. And the compiler, the C program knows, oh, this is how I'm going to handle it. I'm good with it. I'm going to move forward. So implied is pretty easy. You as a programmer don't have to do anything special. It's implied that you thought about converting it, and it will convert it for you. Explicit is pretty much on purpose, where you on purpose decided, I need this to be converted from an integer to a float because that's the only way I'm going to get the right answer in this equation. Or I need specifically for this to be converted to integer value. So I specifically going to say get this value and turn it into an int, and then do the operation I'm requesting. So explicit is pretty much you forcing it by telling it exactly, this is the one I want float, this is the one I want int, and you going around and specifying any time that you want a conversion. So I'm going to show you examples of both types. Implicit, where you don't have to be so clear that you want conversion, it will figure it out on its own. And explicit, which is I'm going to tell you exactly where and when and which variable I want converted, and you do it exactly how I request. So let's talk about when you need each case. So here's an example of implicit, meaning I'm implying that it's going to probably have to do some conversion and I'll let it decide on its own. So it's easy for a developer. In this case, we didn't really have to do anything special. This is how it starts off. First, we have an integer called num, and num is a variable I invented and it has a 3 in it. So now num is 3. I have a character C, which is the letter C. So it's one character, one letter, that is the letter C. And then I have another variable that I invented, a brand new variable called sum that starts off empty. There's nothing in the sum. So on this line here, this is where the actual conversion happens. I say this sum, which I know is of type integer, this sum is going to be the addition of I plus C. So get I, get C, add them together, and put the answer inside of sum. So the system gets this instruction, and it figures out, all right, so I need to add I and add C and put them together. So where's I and where's C? What are the numbers I need to actually add up here? So it looks up I, and in this case, there's no I. That should be num. All right, I'm going to have to start over. This is quite peculiar, you see. I have an integer num equals 3. Let's start this slide over. So here's an example of me doing a conversion implicitly. Now, implicitly means I'm not going out telling you what to convert, when to convert it. I'm letting the C programming language figure it out. So let's see the different pieces on this page. I have num equals 3, so I invented a brand new integer called num. I put the number 3 in it. Then I have a character called C, so I invented a brand new variable called C. I put the letter C in it. And now I have another integer called sum, so I've invented a brand new integer called sum. I haven't put anything in it just yet. So what happens when we go ahead and do calculations on these values? Look at this line here. I say go ahead and get the sum and set it equal to the num plus C. So the compiler thinks, all right, I got this. So you want to get num, add that to C, and once they add together, put the answer in sum. No problem, I got this. But wait, there's a little bit more complexity here. It knows that num is an integer of 3, so I'm going to add 3 plus something. 3 plus something equals the answer. But the next thing is a C, so it's like 3 plus C. How do I figure out how to add 3 plus C? So whenever you're adding a character to an integer and doing this mathematical operation, it thinks I'm adding here. You just give me numbers. Oh, you probably was silly and put a C by mistake. What you really meant to give me was the numerical representation in ASCII of a letter C. So if you were to look at the ASCII table and find out lowercase c, what ASCII value is lowercase c, you will see that ASCII value is 99. So position 99 is lowercase c. And I'm like, oh, so what I'm really going to be adding up is num, which is 3. So I'm adding up 3 plus 99, which is c. So the actual implied conversion was to change that letter c to 99, put it into the equation, and then add. So I have 99 plus 3 winds up being 102. So my answer says value of sum equals 102. So this is an example of implicit conversion. I didn't have to tell it which one it had to actually do conversion on. It figured that because I had that plus sign there, I was trying to add two things, that I must know that I gotta add two numbers. So it's gonna exchange anything that's not a number to a number using the ASCII table. And so right there on this line, it created a conversion implicitly. 3 plus 99 equals 102. And that's how the conversion happened. All without you having to specify yourself. Let's see another example. This one is also implicit, so we didn't have to really go out and tell it what has to convert and when. It's figuring it out during the operations. So first we have a float, and the float is at 2.2. We have another float, value 2, and this one's at 3.2. And then we have an integer result. So integer, you know, can't have any decimal places. It can't handle this 0.2, 0.3. It doesn't know what to do with it. So down here, result, which is an integer. Integers only hold numbers, remember. We're going to put inside of this variable that could only hold whole numbers in it. That's all it could do. Integer could only do whole numbers. And say, go ahead and add these two numbers up and put the answer into result. Well, when I add these two numbers up, 2.2 and 3.2, I get 5.4. So I do this side first, and I add up value 1 plus value 2. So in memory, I'm storing 5.4 as the answer, and I see, wait, it wants to put it inside of a whole number. If I'm going to put 5.4 in a whole number, I need to drop that 0.4 stuff. It only could fit the 5 in there. And so my result winds up being the whole number of 5. It just forgot about the 0.4 because it can't handle decimal places in an integer value. Remember, only floats and doubles can handle these decimal places. So when you put an answer inside of an int value, it goes ahead and gets rid of those decimal places and only has the whole number in that spot. Now there is a little bit of complexity that I haven't mentioned, and that's a rounding. So in this case here, it added up first in decimal places, so it did this half of the equation first. What is 2.2 plus 3.2? 2.2 goes here, 3.2 goes there. So what's 2.2 plus 3.2? The answer is 5.4. And then it decided, oh wait, 0.4 is a decimal place. I got it. I'm going to go ahead and say all I need is a 5 as a whole number. Now in this case here, you may wonder, well, wait a minute. Now we have different numbers. I have 2.6 and 3.7. So these are a little bit higher decimal place values. And watch what happens as I'm going through and doing the arithmetic against them. In this case here, I'm right from the very beginning saying, go ahead and get that 2.6 here. That's value 1. Take 2.6 and turn it into an integer right at the beginning. So in this case here, this is an example of explicitly. So it's the first time that we're saying exactly, change this value to an int, and this is the one I want you to change, and this is the type I want you to change. So whenever you want to change a float to an integer, all you have to do is find where your float is. Value 1 is a float, I see it up there. So after you declare the float, not in the declaration, later on when you're using it, after you have this float value, you put the word int in parentheses right in front of it. Try not to have any spaces, just out of convention. And it says, turn this value, the int representation of this value is what I want you to actually use in this equation. So I'm right here saying, grab 2.6 and do an int value here. And what it's doing is it's grabbing 2.6. It's again chopping off the 0.6, throwing it to the trash, and saying, well, now 2 is all that's left. And now my V1 is set to a 2. So my V1 is a 2 in this case. In this example here, I have value 2. Value 2 is 3.7. And I want to put the int conversion, so I'm saying turn that into an integer for me, and put the integer representation of 3.7 in V2. And in this case, V2, I want to go ahead and say V2 now only has a 3. I'm throwing away that 0.7. It's going away. I'm only using the 3 here. So now I have a 2 and a 3. And I have an integer result. So in the case where I was doing some kind of arithmetic here, I would have value 1 plus value 2. What would the decimal place value be? And what would it be hypothetically if I was adding the two integers? So in this code, I'm not adding the two integers, but let's do that in our head. If I were to say add V1 plus V2, I have a 2 here, I have a 3 there, so I can say 5 is my answer. Great, I've got that part. But what happens here when we're using the actual decimal places? I'm saying go ahead and add 2.6, so I have the 2.6 in my memory, plus add the 3.7. So if I add 2.6 plus 3.7, I wind up getting 6.3, something like that. So my float value would be 6.3. But I'm not really having a result as a float value. So it's going to get rid of the 0.3 and just leave it with the 6. So watch what happened here. If I had the numbers converted first, if I threw away those decimal places first, then I would have had a 5. But here, since I'm actually taking the numbers, adding it first, and then resulting to the result, now I have a 6. So it's a little bit hard to follow. If you want to be precise in terms of your decimal places, you got to pick how early you want to actually throw away those decimal places or keep them around for later. And after the actual mathematical operation happens, then convert it to an integer. It's up to you how soon or how late you convert it, but it does affect your answer. So be careful. So here's another example of being an explicit conversion. And in this case here, we have 3 different integers. Now, this example has all 3 integers on the same line. That's possible by using the comma in between them. But I could have very easily had int a equals 5, a separate line, int b equals 8, and a separate line, int c equals 0. I could put that in 3 lines if I wanted to, but in this way, it's all on one line. So I have 3 integers, a, b, and c. They each have a number assigned. And I have a float called d, which is initially set to 0. So if I say take a divided by b and put that in c, what will be the answer? Now, a, b, and c, all 3 of them are integers. So if I get a, which is 5, divided by 8, 5 divided by 8 comes out to 0.6 something or other. It doesn't come out to a whole number, 0.625, so forth. So if I did it on a calculator and I said 5 divided by 8, I will get 0.628. And I want to put the answer inside of C. C can only do whole numbers. So C is going to take the 0 and get that 0.628 and just throw it away. So the answer to this of 5 divided by 8 is 0. Not mathematically correct. But that's what happens when you have an integer as a result. So C is an integer, which means it's going to throw away the decimal place. But when you divide 5.8, all you have is decimal places, and we threw it all away. So we wound up with 0 as the answer. So be careful when you're doing these kind of arithmetic operations. Now, let's go a little bit further. What if we said, go ahead and turn A to a float, and go ahead and turn B into a float. So now I have all 6 digits worth of actual decimal places. So I have 5.000000, and here I have 8.000000. Now when I divide the two, I actually get the whole decimal places in my value of D, because D is a float. So I said, explicitly I'm saying, you see this A here? I need this A to be turned into a float. And I did that by putting the word float in parentheses right in front of it. Saying, get this A, it was an integer, get this integer and turn it into a float. And I said float right there, saying, this is the one I want you to turn into a float. I did the same thing here. I said B, take B and turn that into a float. And I said the word float in parentheses right in front of that B. So I said if I have float A divided by float B and put that into D, which is also a float, now there's no throwing away of decimal places. I have 6 decimal places to play with that I can put actual answers. And so D actually has the room to fit in the whole answer, which is 0.625000. Remember, it's going to keep all 6 digits because I don't have any kind of number around my %F. So this is how you explicitly do conversion. You actually say what type you want to convert. And this example, we converted from an int to a float. So now I want you to try it. I'm going to put some examples in the description of this video. And I want you to go ahead and practice doing the conversion. Make sure you get your arithmetic right. Don't let it throw away digits that you really wanted to use. That's the lesson of today. Hope you enjoyed it. See you next time.